Hi, I am Dr. Shweta Chaudhary and today's topic of discussion is Fourier series. In Fourier series, we will having a function fx which we will have to expand in a series of sine and cosine. So we can say that a series which is containing the terms of sine and cos is called a Fourier series. Here, one doubt may arise in our minds, what is the difference between the Fourier series and the Taylor series or the Maclaurin series. Here we can say that if a function is continuous and their derivatives are also continuous, then it can be expanded by the Taylor series or the Maclaurin series. But if a function is discontinuous, then Taylor series or Maclaurin series fails. In that time, we will need a different series which is called Fourier series. So we can say if a function is continuous or discontinuous or any type of function, we can expand with the help of the Fourier series. The Fourier series is a series which is having the terms of sine and cosine is called Fourier series. The difference is that with the help of Fourier series, we can expand any type of function, whether it is continuous or discontinuous function. So now what is the application? There are so many applications in the engineering problems which is depend upon the Fourier series, conduction of heat, thermodynamics. There are a lot of applications of Fourier series. Now, second question may arise in our minds, can any type of function be expanded by the Fourier series? The answer will be no. Those functions which satisfy the Dirichlet condition are only eligible to expand with the Fourier series. The function which satisfy the Dirichlet condition can be expanded with the Fourier series. So what is the Dirichlet conditions? There are three Dirichlet conditions. Number one is function should be periodic. It should repeat its value after a certain period, that is called periodic function. It should be single valued. Single valued means if we are having a function fx, if we put some single value of x, we will get a single value of fx. That is called the single valued function. Second is function should have finite number of maxima and minima in a finite interval. Third one is function should have finite number of discontinuity in a finite interval. So we can say that if a function is continuous or discontinuous and if it satisfies these Dirichlet conditions, that function can be expanded by Fourier series. Fourier series is a kind of series which contain sine and cosine series. So here comes Fourier series. Here in this Fourier series, we will be having a function fx. Function may be in the form of a single function, or it may be in the form of graph, or it may be in the form of a table. That is called harmonic analysis. So here we will having a function fx. This is the function and we are going to expand this function into the Fourier series. Fourier series is equals to fx is equals to a naught by 2 plus summation a n cos n pi x by L plus summation n is equals to 1 to infinite b n sin n pi x by L. This series is called Fourier series. We can expand this series from 1 to infinite with the term of cos and 1 to infinite with the terms of sine. Here we will have to find out the values of a naught, a n, b n. These a naught, a n, b n are called Euler coefficients or Fourier coefficients. The value of a naught will be 1 by L integral c to c plus 2L fx dx. With the help of this integration, we can easily find out the value of a naught. Now to find out a n will be 1 by L c to c plus 2L fx cos n pi x by L dx. With the help of this integration, this simple formula, we can easily find out the value of a n. A n and a naught are called Euler's coefficient. Now this is the time to come for finding bn. Bn will be 1 by L integral c to c plus 2L fx sin n pi x by L dx. With the help of these formulas, we can easily find out the values of a naught, a n, b n. These a naught, a n, b n are called Euler coefficients. So first we will have some function fx. With the help of fx, we will put the value of fx and we will get a naught. Similarly, we will be able to get an and bn. After finding all these values, we will have to put this value into this series, and this series is called Fourier series, having the terms of sine and cosine. So this series is called Fourier series. These are called Euler coefficients, where the interval is c to c plus 2l. If in every question the value of c will be changed, if let the interval is say 0 to 2 pi, then we will compare it with c plus 2l and we will get the value of l, which is pi. Again, if we will having the interval of say 0 to 5, then we will compare it with c to c plus 2l and the l will be 5 by 2. So with the help of this interval, we will get any value of L. Now, if the interval is from negative to positive, it may be from minus pi to pi, it may be from minus 2 to 2, it may be from minus 5 to 5. If our interval is from negative to positive, or we can say that if minus L to L or minus pi to pi, where L may have any value, it may be 1, 2, 3, 4, 5, 6, it may have any value. So if our interval is from negative to positive, then there is a tool which is called even odd function. If we will use this tool, our work may be easy. So if you will find in any question the interval is from negative to positive, from minus pi to pi or from minus L to L, where L may have any value, it will be your choice. You can use this tool which is called even odd function. What is the even odd function? Now to check whether our function is even or odd, we will have to replace the x by minus x in the given function. We will have to replace the x by minus x in the given function fx. By changing x by minus x, if we didn't get any different values, then the function will be even. So we can say that if fx is equals to f minus x, then the function is even function. We can understand this even function with the help of an example. Here I am taking an example. Let fx is equals to cos x. If we replace x by minus x, then we will get f minus x is equals to cos minus x. And we know that cos minus theta is equals to cos theta. So cos minus x is equals to cos x. So there is no change in the function after replacement x by minus x. In that situation, we can say that our function is even function. So if fx is equals to f minus x, then the function is called even function. With the help of graph, we can easily understand the concept of even function. If we will draw a graph of any function and the graph is symmetrical about the y-axis, then this function is called even function. Here again I am taking an example. Let the function is cos x, and if I wish to check whether it is continuous or discontinuous, I can draw the graph of cos x, and with the help of this graph you can easily identify that graph is symmetrical about y-axis. Hence this function which is cos x is even function. Now if our function is even function, so what is the benefit of it? So in the time of integration, if our function is even, limit is minus pi to pi or any limit from negative to positive, then the integration will be twice of 0 to pi fx dx. Actually what is happening, with the help of the graph, we can easily see they are the mirror image. If we will find only this interval, this function, we can twice this function. So Here in integration, no need to go from minus pi to pi. There is no need to go from minus pi to pi. You can solve within the interval 0 to pi and you can twice the result. So easily you can find the integration because the lower limit becomes 0. And due to this 0, your calculation part will be very simple. So it's better if you will see any limit from negative to positive. It's better to check whether your function is even or odd. If your function is even, then you can do twice of the answer by taking lower limit 0. Again, if your limit is from negative to positive, now to check what is the odd function, again to identify the odd function, you will have to replace x by minus x in the given function. If after replacement you will get a difference of negative sign, then this function is called odd function. So we can say that if fx is equals to minus fx, here you can easily see the difference of negative of the function. Then this function is called odd function. We can take so many examples as fx is equals to x, x cube, sin x. There are so many functions which is odd. Here again I am taking an example. Let fx is equals to sin x. Now to check whether it is even or odd, so we will have to replace x by minus x. If after replacement we will get the negative sign, then this function is called odd function. If this function is odd, so we will get the benefit that integration minus pi to pi fx dx will be directly 0. So this thing we can easily understand with the help of the graph. If I'll draw a graph of sin x, you can easily see this graph is symmetrical about the origin. This portion is opposite to this portion, so the integration will be 0. So with the help of graph, you can easily find out whether your function is even or odd. This is the tool. You can, if you wish, you can use it, or without using these tools, you can easily find out your answer. In even function, the graph is symmetrical about y-axis. So if it is symmetrical about y-axis, no need to go from minus pi to pi. You can simply solve from 0 to pi and take the twice of this answer. But if your function is odd, if your graph is symmetrical about the origin, then your integration will be 0. So this is the tool of even and odd function, which is only used when your limit is from negative to positive, from minus pi to pi, from minus L to L, or from any other negative value to positive value. In that case, you can check whether your function is even or odd. Otherwise, you can solve your any question with the help of Euler coefficients A0, An and Bn. Thank you.